The title of this topic is Basic Initial Stability Nomenclature.
The basic nomenclature for initial stability of a ship includes the following terms. GM, the metacentric height, which is the distance between the center of gravity and the metacenter. Kg, the height of the center of gravity from the keel. Km, the height of the metacenter from the keel. Kb, the height of the center of buoyancy from the keel. Gz, the righting lever, which is the horizontal distance between the force of weight and volume. B, the center of buoyancy. M, the metacenter. G, the center of gravity. Pi, the angle of heel. Explanation. The metacentric height, which is GM, is a measure of a ship's initial stability. A higher GM value indicate better initial stability. Initial stability is the resistance of a ship to small changes in a difference between the vertical forces applied on its two sides.
As stated, ship stability refers to a vessel's ability to bounce back to its upright position or stay balanced after being tilted by an external force like wave, wind, or cargo movement. Next is the factors affecting stability. It is the shape of the hull, the draft, and the trim all affect the stability of a ship. The key factors affecting stability is first, hull shape. It is the design of the hull determines how water is displaced and how the center of buoyancy shifts when tilted. For example, a wide, rounded hull typically has a higher metacentric height and better initial stability than a narrow, deep one. Conversely, some hull shapes are optimized for better stability in rough seas over long distance. Next is draft. This is the vertical distance from the waterline to the keel. A deeper draft lowers the center of gravity relative to the metacenter, which can improve stability. However, too much draft may restrict navigation in shallow waters and can also affect how the hull responds to waves. Last is trim. It is the longitudinal tilt of the ship, or bow up or stern up. An even trim shifts the distribution of weight and buoyancy along the vessel's length, which can alter the position of G and B. Proper term ensure balanced forces and maintains optimal stability. Next is the diagram. This diagram illustrates K stability related points and distance for a floating vessels like a ship or a boat. First K points is the M, the metacenter, the intersection point of vertical lines through B when the vessel is upright and when it is slightly held or tilted. Next is the G, or the center of gravity, the point through which the downward weight of the vessel acts. Third one is B, or the center of buoyancy. This is the point through which the upward buoyant force acts, or centroid of the displaced water volume. Last is the K, the lowest point, representing the vessel's keel, baseline for measurements. Next is the K distance. First is the GM, or vertical distance from center of gravity to metacenter, known as the metacentric height. A positive GM indicates the vessel is stable and will return to upright when held. A negative GM means it is unstable. Second is the BM, or the vertical distance from center of buoyancy to metacenter. It relates to the vessel's hull shape and is calculated as the moment of inertia of the water plane area divided by the displaced volume. The next is KM. This is the vertical distance from keel to meta-center. Next is the kg, or the vertical distance from keel to center of gravity.